Well, thanks to anyone who's actually interested enough to come and stay for my talk rather than going and see Zubrin next door. It's a tough compete. This was one of the projects that I did with one of my colleagues, Luis Sariva, on Crew 89 at MDRS this past year. This was working a second ago. All right. There we go. All right. It works from this side, not the other one. We'll try that. Okay, so one of the oh, sure. Great. Okay, there we go. All right. So one of the problems they had before we arrived was that the shower broke. And so when we were facing the possibility of going and spending 2 weeks without a shower, and one of the other proposed projects that one of the crew members wanted to do was an exercise program. So 2 weeks with heavy exercise and no showers didn't really seem like a great combination for making new friends. So what I did was I put together a system for a self-contained system for doing a recycling shower where we would collect the water from the shower and then filter it and treat it and then basically use it again as long as we could show that it met safe bathing standards. And so one of the other benefits of installing something like this permanently at MDRS would be that they have an extremely limited water supply. You get basically, I don't know if any of you guys have been on a crew, but you get basically a tank of water gets brought out, and that's it. You run out of water, you'd better hope that the roads are in good enough condition that DG or whoever is doing it can come and bring you some more water. But in general, you're limited to what you got, so you've got to be careful rationing your water. At the moment, the nominal thing was 2 Navy showers. Basically, you switch it off, you soap up, and then you rinse it off, and you do it all as quick as you can. And hopefully you get away with only using a gallon or 2 of water. And you're limited to 2 people having showers per day. So another part of the idea was that if we could introduce a recycling system and not necessarily have 100% reusal of the water, but at least, a reasonably high percentage reusal, then everybody could have a shower every day, and particularly if you were working hard, then hopefully we'd have some better morale as well. Unfortunately, on our second day there, we found out what the problem with the shower was. Basically, they'd had a hard freeze about a month before, and one of the pipes had burst. So, what we did was, we fixed the shower. So all of a sudden, people were a little bit less enthusiastic about bathing in recycled water when there was a nice, perfectly good working shower there. But we went ahead and we built it and we tested it and did that stuff anyway. This was basically a kind of an ad hoc system put together. We weren't allowed to touch any of the water lines in the actual hab. Generally, that's kind of a no-no without the advance permission. So for a demonstrator, basically all we had was a simpler system as we could build and put together as possible to demonstrate the feasibility. So basically, we took a bucket. We thought about putting a water heater in it independently, but then at some point somebody said, well, you could just heat that water up on the stove and just skip the extra heater. We put this up on high up on the second floor as we can. We considered putting it up in the loft, but there wasn't a good. There are good little holes in the floor between each of the floors, but there wasn't a very good one going up to the top loft space. So this ended up about 15 feet higher than where the shower stall itself was. To aid with the gravity feed, we stuck an air compressor on it as well to help give it a bit of a push. Something you might want to do, and if this ends up getting implemented for real, is to put a proper water pump in rather than an air compressor. But this was an air compressor that's actually used for filling up the tires on the ATVs that we knew was there, we knew it was available, we knew it worked, and so all we had to do was stick a car valve in the bucket and seal the top on the bucket down. So super easy to do, and all we did was underneath the hab. There's some loose pipes so that when they've got some expansion room to freeze, and you can collect the water at the bottom of that, and that we could then process. Okay, so I briefly mentioned pressurizing the system so we could get a bit more water pressure rather than just your 15 feet of head, which actually, even without that, we did, two of us took showers in this system without having it pressurized, and it was actually perfectly acceptable. I'd say 15 feet is probably the minimum, like 20 or 25 feet of head would have been really good, perfectly nice pressure, but nevertheless, it worked fine. You can see the little plumbing valve that we added so that we could pour water in once we'd sealed this lid on, and then you can see the little valve that we attached so we could pressurize it. Just based on filling this thing up with water, we found that 50% boiling water off the stove and 50% cold water actually gave a very nice lukewarm temperature that was nice to have the shower in. So once we'd collected the water, as I said, the pipes under the hab, you stuck a bucket under, disconnect a little bit, stick a bucket under it. And so we collected the water, and we got an extra bucket. This was a 12-gallon bucket. We used a 5-gallon bucket for the shower. If you have a flow rate of 1 to 2 gallons per second, if you have a low, if any of you guys at home have a low shower, a low volume shower head, that's delivering 1 gallon per minute. So basically, we were figuring you had about 5 minutes for your shower. So collecting the water, people use like sand and charcoal filters and all sorts of stuff. We basically said, well, let's use sand because there's plenty of that on Mars and there's plenty of it around MDRS as well. There's a whole hill right next to MDRS that's made out of sand. So let's just come along, dig up some sand, chuck it in the bucket. Okay. Once we'd filtered the water to get rid of most of the solids, I'll show you some of the photos, little samples later. Just putting it through that sand, when the water went from being cloudy, full of soap and oils and stuff, to being pretty clear. However, not really sure it was getting rid of any bacterial content. So basically, you get these little UV lamps that you can use for hiking and camping and stuff and cleaning water that. So we didn't give it the full amount of dosage that the UV pen manufacturers claim you need to fully sterilize water, but we weren't trying to drink this stuff. I don't think any intention of drinking it. We were only looking at reusing it to have another shower in it. So we gave it, we kind of just ballparked out. We figured we'll give it like 5 minutes worth of dosage, and we'll test that afterwards, and if we're overkilling it, then maybe we can get away with a couple of minutes. Or if it's not doing enough, then we'll just give it a bit more UV next time. So here's the shower water that was collected after the shower, and you can see that's pretty opaque. You can't really see anything in the background behind that. You can see the change from the black to white here, and you don't see any change really going on in there. And after you filtered it, it's pretty clear, and you can see right through this. It's got a slight yellow tint to it. The first time we did this, we used some commercially bought sand. And we think they dyed the sand yellow to make it look more appealing and sand-like, and all that dye then came out. Basically, there are different water standards around different places in the US and different places, but the minimum standard for bathing, like this is, if you go to a beach in the EU, and if it's considered safe bathing, then this is the standard. There's 100 bacterial units per milliliter, as a maximum, and 20 as a maximum of gram-negative. Gram-negative means bad bacteria, or typically indicative of bad, like E. coli, stuff basically from poop that you really don't want to be bathing in and certainly not drinking. So it's indicative that there's probably high quantities of really nasty bacteria that can cause some serious illness in there. So you need to keep those down to low levels. And there's a couple of different plates that you can use if you know anything about microbiology. And you can add this stuff called red bile, and that's what makes these red plates. And that kills off any gram-positive, so you only have the bad bacteria growing. So any of these spots, all these spots here that you're seeing on this plate, that's all the bad bacteria that you really don't want to be bathing in. So these were the results. First of all, the water coming straight out of the tap. This is normally drinking grade water, and yep, we didn't find any bacteria at all, and we didn't find any bad bacteria, so that water is safe to drink. After the shower, so you remember I said 100 colony-forming units per milliliter is the most you can accept in total bacteria. We've got 100 times that. And I also said 20 of the red ones, the bad ones. Again, we got 100 times the limits. So really, this is not safe water to shower in. You shouldn't shower in water after somebody showered in it. So basically, that said we needed to do a bit of processing. Well, we kind of knew that ahead of time anyway. So we then ran it through the sand filter. Well, that did miracles in itself, just running it through the filter. All of a sudden, we're down to 250, and we couldn't even detect sorry, we didn't do the test for the other one. We only tested for the bad ones. But that did a great job on its own. But it's still not within safe bathing standards. And then when we added a little bit of UV to it, then that brought that the limit there was 20. So we were at a quarter of. So that's this water here. After we've run it through the sand filter and put a UV dose in, that's perfectly safe to have another shower in, basically. Okay, these are just the details of exactly how much UV we gave it. To reach drinking standards, we estimated that we needed to apply 20 minutes of UV dosage with this lamp rather than 5 minutes. I think the answer really would be get a bigger UV lamp. And that, if somebody wanted to go the extra step and try reprocessing some of this water to bring it up to drinking standards, you'd also need to look at the mineralogical and the solids content of the water. If anybody came and saw your talk earlier, they've seen some of that stuff. So we only looked at bacterial levels because, as I said, we were only looking at bathing in it. But if somebody wanted to go that step further, they certainly could. Okay. So the other thing is, okay, this is great, and I'm basically designing this to, as an improvement to MDRS. But the question is, could you use this on an early, like a first base on Mars? Well, all we needed was UV and sand, other than the water. And presumably you've brought the water with you, or you're digging it up from ice, or you're, if any of you saw the regolith water and oxygen extraction presentation yesterday, you've got your source of water, you've cleaned it up, and to keep going, all you need is sand and UV. Well, there's plenty of sand on Mars, at least assuming depending on where you've picked your location. And so the question is UV. Well, what's the UV dosage on Mars? And so there's an EPA minimum of the dosage that you need to apply, and that's basically 2.5 millijoules per centimeter squared on like a sheet of water, if you like, of UVC. UVA and UVB aren't particularly good at killing bacteria. UVC is very, very effective at killing bacteria and viruses and the like. And the UV penetration depth is 1 meter, so that means that you could get away with a tank of water anywhere from a few centimeters up to a few tens of centimeters of depth. Now, if you try to do this on Earth, at the equator, the dosage is about 4 times 10 to the minus 9 watts per square meter, and that would take you 7 days in the sunshine. So if you're out in the desert, you're probably not going to see much life unless it's hiding under a rock. But if you've got any reasonable chance of shade, you're going to be fine.